right, here's our video, part 2, Algebra 1 Regents review. Some of the questions you'll see on the test, some actual questions. So let's make sure we have our pen ready, and let's get a clean page. All right, and we'll start with yellow. So again, I'm going to be putting actual questions that appeared on the tests throughout the years. So let's look at this one. Let's say you had if f of x equals 3x plus 4 over, fix that over 2. All right, then what is f of 8? What do you think that would be? So you can pause the video if you want, or I'll just keep going. So again, just plug in 8 for the x, right? So this would be 3 times 8 plus 4 over 2. And we'll put a little arrow over there. So you're going to have 24, because 3 times 8 is 24, plus 4 over 2. You're going to have 28 over 2. We'll fix our 2's there. And we know that f of 8, then you could say over here, f of 8 would equal 14. All right, let's do another one. Let's clear this out. All right, let's clear that out. So let's say you saw that said the expression 36x squared minus 9 is equivalent. What's it equivalent to? So we could factor this out, right? And if you notice something right here, you see the difference. That's that subtraction sign, the difference. And it's not just the difference. It's the difference of perfect squares. You can take 9, right? The square root of 9 is 3. The square root of 36 is 6. Right? So anytime you see the difference between two squares, perfect squares, it's going to be a plus and minus. So you're always going to see a plus or a minus. Plus and minus. And. Use the word and. So if we think the square root of 36 is 6, and the square root of x squared is x, and the square root of 9 is 3. So we have those three elements right there. So we're going to say 6x plus 3. And what did I say? If you have the difference of perfect squares, you're going to have plus and minus. So it'll be that, and then 6x minus 3, and we're timesing it. So that expression is equivalent to this with two binomials. All right, let's keep going. All right, let's use green. Change it up to green. Let's say that you said if the point and you have a k negative 5 lies on the line whose equation is 3x plus y equals 7. Little comma there. Then the value of k, what's the value of k? What do you think the value of k is? So, I mean, just look at this. We have 3x plus y equals 7. And up here, so change the color for a minute, we know that the first number is always x, second number is always y. We know that on the line. So we don't know what x is, but we have y. Shows it right there, right? There's our little arrow. We have negative 5. So it's 3x, and it's plus negative 5 equals 7. Just add the 5, right, on both sides. Add it on both sides. And now we're saying 3x equals 12. And we're doing some algebra. Divide out the 3. So we know the value of k will be 4. Moving on. And clear that. Go back to green. So let's say it said if x did not equal 0, then the common ratio of the sequence, now you got the sequence coming, and here's the sequence. Common ratio of the sequence x, 2x squared, 4x to the cubed, 8x to the fourth, what would be, and then, we'll put another one in there. Let's say 16x to the fifth, right? You can see the pattern already. So the ratio, the common ratio is what? What would be the common ratio? If we think about how we got 2x squared, right? We had x. We know x equals x, right? And if we had to get 2x squared from x, we have x, we need 2x, right? We need 2x to get 2x squared, because if we distribute that, 2x times x is 2x squared. Well, how are we getting 4x cubed? The next term in that sequence. Well, if we did 2x squared, the number before, right, and we times it by 2x, what would we get? 2 times 2 is 4. X squared times x is x cubed, right? So you can see this recursive sequence. What happened before? Let's look at the next term, 8x to the fourth. Well, if we take the term 4x cubed, what we got before, and we times it by 2x, do we see a pattern already? 4 times 2 is 8. X cubed times x is x to the fourth, right? So, I mean, we can see this 2x right here. That 2x is appearing over and over again. So the common ratio is 2x. And if you just wanted to see it one more time, look at the next term, right? We had 16x to the fifth. So what should we do? Use the term before, right? 8x to the fourth. And the common ratio is 2x, right? So 8 times 2 is 16. X to the fourth times x is x to the fifth. And you can keep going. So there's the common ratio. All right. Clear that out. Let's go back to yellow for a while. So let's do a function here. And let's say I had a box. A function box here was 1, 2, and 3. And we had another box over here. Remember, this is the x and the y. This will be the input. That's the output. This is the domain. The domain is x. Domain, right? It's the domain. And y is the range. Input, output, so forth like that. Let's fix that E. Weird looking E today. And let's say you had A and B and C, and we have 1 mapping to A, 2 mapping to B, and 3 mapping to C. So this will be a function, because in a function, very important, in a function has one and only one value of y for every value of x. In other words, 1x for 1y. That's it. I mean, y could have different x's. Like you can have this. This could be a function. So this is that's a function. Yes, it's a function. If you had 1, 2, and 3, and let's say you just had A and B, so 1 was from A and 2 was from A, you can do that. Right? The y, the output, could have multiple x's, but the one x can only have one y. So this would be a function. Yes, that's a function. All right, so let's clear that out, and I'll give you another one. See if what you think this one is. Right? Let's say we had 1, 2, 3, 4. We had a little box there with the input. We'll call that the domain, the x, and over here the y. What's the y called? The range. Right? You got it. We have the range over here. And we had A and B and C. And let's say we had 1 for A and 2 for B, and 4 for C. Do you think this is a function? Well, you do have one x for one y, but there's this one right here. The 3 has no range. So this is not a function. Not a function. Every element, write that down, every element in the domain needs a y. Just make it in simple terms. Needs a y. Needs a range. And you can see the 3 has no range, it's not mapped to anything. So this is not a function. All right, let's do one more question. All right, so let's say we had the expression. Let's say the expression 1/3 x 6x squared minus 3x plus 9. And we'll say is equivalent to what? What is it equivalent to? So what should you do here? Distribute. Make sure you distribute. So distribute that out. What would you get? Well, 1/3 x times 6x squared. 1/3 of 6 is 2, so it's going to be 2x cubed. 1/3 x times negative 3x is going to be negative x squared. And 1/3 x times 9 will be 3x. So there it is. We took this expression. It's equivalent to this. All right. All right, that's part 2. In part 3, we'll do more questions that appear, actual questions on the test.